Hello dear participants, I welcome you all here in this lecture number 37 today. The title of today's lecture is Test of Reliability Cronbach Alpha. Objectives of today's lecture are as follows. The first objective is to make you all familiar with the reliability test Cronbach Alpha. Second objective is to make you all familiar with the procedure to obtain Cronbach Alpha value using MS Excel and SPSS. And third objective is to make you all familiar with the reading and interpretation of the result, that is Cronbach Alpha value, which we obtain using MS Excel and SPSS. So let me start this lecture with some sort of an introduction. So once we are having data in our hand, then before going for the analysis of the data, one should go for the testing of the reliability. And what actually we do here in the reliability testing? Here we actually test the reliability of the questions or questionnaire. Here we try to find that whether the questions are addressing the reliable output or not. And there are different tests available here to test the reliability, like test retest is there, iterator is also there, parallel forms is also there, then the internal consistency is also there. The Cronbach alpha for internal consistency is widely used and the popular one. But what actually we need to have in our data to perform the Cronbach alpha? What are the prerequisites and how does it work? All this part that we are going to discuss in the today's lecture. So let me take you all to the Cronbach alpha reliability test. So the Cronbach alpha is an indicator of internal consistency of the scale. And what is the prerequisite to perform the Cronbach alpha? That should be there in our data. So in our data, we should have the multiple items measuring the same latent variable. Now to understand this prerequisite, we need to understand the meaning of latent variable and the meaning of this terminology items. Right. So let me start with the latent variable first. So what is latent variable? Latent variable is also known as a construct. Fine. If a variable that cannot be measured directly, then it is referred as a latent variable or the construct. For example, if we are measuring the satisfaction level of the students or the participants of a particular lecture, or say that our certificate course, or if you are measuring, say that the happiness after reading a particular book or after seeing a particular movie or kind of any activity, then, or suppose if we just want to measure the openness, fine, when we are having such type of the variables which we cannot directly measure, then such variables are known as a latent variable. On the opposite side, if we are measuring the height, we are measuring it in a centimeter. If we are measuring the weight, we are measuring it in the kilogram. But there are few variables which we cannot measure directly, and in that case what we do, we ask few bunch of questions for each such type of the variable, and those bunch of questions will give us an idea about that latent variable. So this is the way that we measure the latent variable. Fine. Now let me take you to the second here term, that is scale. What is scale? To measure the latent variable, we use a particular scale. And what is the scale? Scale is a group of questions arranged in such a manner to measure the latent variable. All those questions jointly measure the latent variable. Now what is the item? Items, individual questions in a group represents an item of that latent variable. More specifically, if I'm asking my participants about the satisfaction level, and for the satisfaction level I'm asking question number 1, question number 2, and say that question number 3, there are different three questions. Fine. And for these three questions I'm going to get the responses in 5 level Likert scale. Fine. Say that highly, extremely satisfied, or the satisfied, neutral, poor, and very poor. So what would be the pattern of these responses from the different respondents? Is there any correlation between these three questions? Is there any particular pattern? and that is the way that we determine whether this data, whatever the data we collected, whether that data is reliable or not. All the questions or items should measure the same latent variable. All these three questions, they represent the satisfaction level. They will lead you to some sort of a conclusion for the satisfaction level, and on these questions we can perform the Cronbach alpha. So what actually the Cronbach alpha measures? The test of reliability here in the Cronbach alpha, it tries to find whether the responses to the various items, responses to these different questions from the same latent variable matches or not, whether they are correlated or not. That we measure here using the Cronbach alpha, and whatever the value we get here in the Cronbach alpha, on the basis of that value we decides whether our data is reliable or not. So how it works, that we are going to see using one example. But before that, let me explain, or let me here highlight that how the different values represent the different type of or different kind of the reliability. For example, here if we compute the Cronbach alpha using software or using the formula, and if that value Cronbach alpha is greater than 0.90, then your internal consistency is excellent. It means your data is highly reliable. It will give you the proper output. If Cronbach alpha is greater than 0.80, still it is a very good reliability. Internal consistency is very high. Cronbach alpha, if it is greater than 0.7, then it is acceptable. But if it is just in between 0.6 and 0.7, then it is questionable. If it is greater than, say that 0.5 but less than 0.6, then it is been considered as poor, and if it is less than 0.5, then it is unexpected, unacceptable. Fine. So we should have Cronbach alpha more than at least 0.7, then we can say that our data is reliable. If we are having the larger number of atoms, larger number of questions, then it gives larger number of Cronbach alpha, and alpha assumes the questions are measuring only one latent at a time. Suppose I'm having the three or four questions associated with the satisfaction level. So satisfaction is one latent. Second is the happiness. For the happiness, again I'm having different 2-3 questions. Then I cannot perform Cronbach alpha altogether. First, I'll have to perform Cronbach alpha here on the satisfaction. Then separately, I'll have to perform Cronbach alpha on the happiness. Fine. So let me now demonstrate that with one example, that how can we compute and how can we read and interpret the Cronbach alpha value. Here is one example. Suppose we want to measure the efficacy of a particular lecture or a course, say that our certificate course, and for that I am asking 4 questions. All these 4 questions are actually leading me to the efficacy of the course. All these 4 questions will give me some sort of a conclusion, some sort of finding for the efficacy of the course. And how am I going to get the responses? Here is the Likert scale, 5 level: extremely good, good, satisfactory, poor, and extremely poor. My respondent will just tick any one for each question. Fine, for any one for the each question. So this is the way that I am going to get the responses. Now suppose my sample size is 50 and I have collected data on this question, efficacy of the course. So here is my data. Here is my question number 1, question number 2, question number 3, and question number 4. Each question is a separate item. Fine. This is a term that we are going to use for the one latent variable. Latent variable. Fine. So what are the questions? Let me go back and see the questions. The first question: how is the content delivery? So my respondent is going to just quote any one of the option. Doubt clarification during the course, how it was, extremely good, good, satisfactory, or what. Evaluation method utilized, how was it? Fine. And finally, the participants understanding, student understanding about the content. On the basis of these 4, I am going to find the efficacy of the course. And here in the Cronbach alpha, I'm going to test whether the responses here, here, here and here for the different questions, whether all they are associated, are they going in the same pattern, are they consistent in the manner. So that we are going to find here in the Cronbach alpha. Now here is the data. So Q1, Q2, Q3 and Q4 is kind of a coded things. So here are the codes 1, 2, 3, 4, 5 for the extremely this extremely good for 1 for the extremely good, code 2 is allocated assigned to good, 3 is assigned to satisfactory, 4 is assigned to poor and 5 is assigned to extremely poor. And this is the way that we have compiled our data. Now how to compute Cronbach alpha? To do that, let me take you to the Excel sheet and let me go to say that here to the data. In data, I'll go to data analysis. I'll click on the data analysis and here a new window appears, and in this window, pop-up window, I'll go to the ANOVA 2 factor without replication. Again, I repeat, here in the data analysis, I'll go to the ANOVA 2 factor without replication. Then I'll simply click on OK. Now I'll have to select the range. So what I'm going to do, I'm going to select all this range Q1 to Q4, all my data. If I select all my data, then simply I'll go to the output range. I'll select any cell where I just want my output and then I'll click on OK. As I click on OK, the result appears. Now here are the two tables. The first table will avoid, will scroll down and will go to the last table. And here is the table where we are interested in. Now in this table also, we haven't got the Cronbach alpha. To find the alpha, we need to go for a particular formula, and that formula is 1 minus mean square of error divided by mean square of rows. So this is the formula, inbuilt formula in the MS Excel. Now where is the mean square of error and where is the mean square of rows? So here is the mean square, here is the row. So this value is associated with mean square of rows, and here is the error, here is the mean square. So this value is associated with mean square of error. Now I'll put these values, I'll perform this function here in the MS Excel is equal to sign, then 1 minus in bracket, I'll simply take my cursor to this thing, mean square of error. I'll click on this thing, then it will get identified, selected, divided by, I'll just simply go to this cell and I'll select on this. So it has identified that particular set, mean square of rows, and then simply I'll press enter. As I press enter, I have got the Cronbach alpha, and that is 0.90. It means this data is highly reliable. This data is highly reliable. I can go for the analysis part. Fine. So this is the table where we already have seen that if my Cronbach alpha is greater than 0.9, then the internal consistency is excellent. Internal consistency is excellent. Now let me take you to the SPSS. How to obtain Cronbach alpha here in the SPSS. For that, we need to import our data, and for that I'll go to File, Open Data. Then I'll go to the location of my file. I'll select that file and I'll click on Open. And again I'll click here on OK, and here is my data. Now the first step, I need to go to variable view, and in the variable view I need to redefine my variable. So I'll put all my labels, then I'll go to the values. Here I'll have to give the codes, because if you all remember that the data that the way I have collected is the Likert scale data. Fine. So here I'll put all the coding 1, 2, 3, 4, 5. I'll assign codes to the attributes and then I'll press OK. And the same way I'll put all these codes to the question number 2, 3 and 4, because all these items, all these questions, I'm going to get the same pattern of the responses on the 5 Likert scale. So that here is the coding, then I'll verify how is the measure, that is ordinal and other things I have verified. Then I'll go back to the data view, and now my data is ready. to perform the Cronbach alpha. Then how to perform the Cronbach alpha, how to obtain that value, that alpha value? For that, simply I'll go to the analyze, then I'll go to the scale, and in the scale I'll go to the reliability analysis. And in the reliability analysis, simply what I'll do here now, as I click on that reliability analysis, a new pop-up window comes. Now here are the different variables. Then I'll have to select the variables, I'll have to select the items which are associated with only one latent variable. There are chances that when we collect the data, we are having plenty of variables with us, and different variables are associated with different latent variables. Fine. We should be very careful when we are performing the Cronbach alpha. We should select those items which are associated with the particular latent variable only. Here these 4 questions are associated with the satisfaction level of that particular course. So I'll select all these questions, and I'll just put all these questions in this box, right hand side items box. Now I'll click on the model. So there are different models like alpha, split half, and there are many, but the alpha is one of the popular, so we'll use the alpha. Fine. Then we'll click on the statistics, and in the statistics again there are many things, but I'll click on the scale if item deleted, and this is very useful. How it works, that I'll explain you. Then simply I'll click on continue, and then I'll click on OK. So here is my result, and in this result, here is my Cronbach alpha, that's 0.904, highly reliable, excellent, fine. Now if I come to this table, item total statistics, and here is the thing, that is Cronbach's alpha if them items deleted. What does that mean? It means here is the Cronbach alpha for all 4 items. Number of items are 4. It means there are 4 questions. 4 questions which are trying to measure the satisfaction level of particular guest lecture or a certificate course. Fine. Now if I delete this content delivery from my data, if I remove this variable, after removing this variable, then our Cronbach alpha would be 0.848. It will reduce. It was 0.904. If I delete this variable, then it has declined. So this is not good idea to remove this variable. Fine. Now come to second, doubt clarification. If I remove this variable, then my Cronbach alpha would be 0.93. Whether this 0.93, whether the reliability improved? In previously when I computed this, it was 0.904. It has now improved. It means this variable played the crucial role here, so that the Cronbach alpha was less as compared to this. So this, now it is completely depends on the researcher whether you want to delete that particular question or not. It is up to you. Fine. Now let me take you to the further. If I go and if I delete this evaluation methods utilized, if I remove this variable from my data, then my Cronbach alpha would be 0.830. Again, there is really no need to remove this, right? And finally, again for this understanding of the content, if I remove this, again it will decline. So there is no need to remove this. If suppose if we want to remove any particular item which is affecting our reliability, then that would be the doubt clarification. But again, though I include the doubt clarification, my reliability is means excellent, highly reliable, so there is really no need to remove any item. There are some circumstances, there are some situations where a particular item, if we remove, then your Cronbach alpha is means it, this value is, if here we are getting a very high value, then we should go for that. But here already we are having a very good number. If here the number is say that 0.72, and say that the doubt clarification if I remove, and my Cronbach alpha becomes 0.93, then definitely we should remove this thing. Fine. So this is the way that we interpret, we give meaning to these numbers, and this is the way that Cronbach Alpha perform here in MS Excel and SPSS. Cronbach Alpha only works with the latent variable, fine, which is having the different items. So this is the way that the Cronbach Alpha works. So here are the results for the MS Excel output and SPSS output. Output is same. So if you are comfortable in MS Excel, you can go with the MS Excel. If you are comfortable in SPSS, you can go in SPSS. So here we'll stop for the today's lecture. I hope you all have enjoyed today's lecture and you will use this Cronbach Alpha for your data. Thank you for your kind listening. See you soon in the next lecture. Thank you.